Today we're going to be talking about box and whisker plots. This is a new display that most of you haven't had any practice with in elementary school, but some of you may have seen them. We're going to talk about the parts of the box and whisker plot, and we're going to be interpreting box and whisker plots today. Alright, the box and whisker plot represents a distribution of values in a data set. So we're talking about the spread, of the values and the variability. All box and whisker plots are constructed from a 5-number summary. Okay, so that lets us know we can't see all of the parts of data. We're only seeing the 5-number summary. Okay, the first one that we see will be called the minimum. And another word for that is lower extreme. Some people abbreviate that as LE. And then we have the lower quartile. Some people call that Q1. This could be LQ. All of these you're going to notice are the measures of variation that we have talked about previously. This one is the median. This one would be the upper quartile, which is also called Q3. And then the maximum or upper extreme. Lots of different terminology for the same part. We also can see outliers, but that is not included in the 5-number summary because not everything has an outlier. And now we're going to look at the display. This is a box and whisker, and you can see exactly where it gets its name. You have a box, and we have 2 whiskers on the ends. Okay, and good thing for you, I've already put them in order for the 5-number summary. This is our minimum. This is Q1, or the lower quartile. In the middle of the box in the whole display is the median. Very nice. This is Q3. And this one is our maximum or upper extreme. As you can see, there are sections, it's divided into 4 sections. That would be your quartile. So here's 1 section, 2, 3, and 4. When you have something that's divided into 4 sections, that gives you quarters or quartiles, which gives you a percent. A quarter is 25% for each section. So we have 25%, 50% is below the median, 75%, 100% of the information. Now, where people get confused is they say, well, if they're all 25%, then why are there different size pieces? Well, that is because the numbers from your specific data set for that section are less spread out than others. So it just depends on the data set. Don't think that because each section is 25%, the pieces or these sections will be the same length because the variability changes for those. Alright, so what we're going to do is practice just reading them now that we know the parts. This is called a double box and whisker plot because there are 2 of them. You read them the same. We have 1 number line. You see there's 1, 2, 3, 4, 5 parts. 1, 2, 3, 4, 5 parts. So we have all the parts that we need. The key here, guys, is to make sure that you read very carefully and understand the question. How much more expensive is the median price at Sophie's Cafe than the Red Brick Grill's median price? Alright, well, where's the median for Sophie? Your Sophie's median is 7. And the median for the red brick grill is in the middle of our box, which is 6. To find which one is more expensive, we're going to subtract the 2 and you get $1. Make sure you use your labels for these questions because we need to know what we're talking about. Compare the interquartile range for each restaurant. Well, remember from our measures of variation, the interquartile range is Q3 minus Q1. Alright, so for the red brick grill, we need Q3. And if you forget, we have that diagram up here. Q3 is the end of the box on the right-hand side. So that would be 7 minus Q1, which is the beginning of the box, 5. So the red brick grill has an interquartile range of $2 in their entree prices. So that's not very spread out. There's a lot. It's very consistent data. All right, now let's try Sophie's Cafe. All right, Q3 is 8. Q1 is 6. So again, we have $2. So if we're going to compare them, they are the same. Now if one was more than the other, then you could explain that. You would say this one has a greater interquartile range than the other, but they are not different, so we're leaving them the same. All right, now the next section is a single box and whisker plot, and it's asking about the percentages for this one. Okay, so let me move this so we can see the bottom of our page a little bit better. Maybe not. All right. What percent of the data is between 3 and 8 eggs? So we're talking about the number of eggs that are laid. What percent of the data is between 3, so this is 3, and this one is 8. So that would be the interquartile range. So what percent is that? Each section, remember from the top, is 25, 25, 25, 25. So when we look at this one, we are going from here, and if it bothers you that there are no points, you can put the points, to here, and then to here, which is 25 and 25, so that would be 50% of your data. What percent of the data is greater than 3 eggs? All right, so if we're here, 25, 25, 25, 75% of our data. True or false? The maximum number of eggs laid is 12. A lot of people would say true because they see 12 on the number line, but is there any data listed above it? It's not included in the box and whisker plot, so that lets us know this is just the number line. There's numbers all over the number line. Our data stops here, so that would be our maximum. This one would be false. All right, I think I've given you a good idea of how box and whiskers work and how to interpret them. So what I want you to do is I want you to pause the video and I want you to answer 7 to 16. Come back and we'll see how you did. Welcome back. I want you to pause the video and check what you did so far. Everything was pretty self-explanatory, I believe. I did put a couple little notes in here for the problems that you may have had a little more work to do. I do want to talk about number 16. Can you determine the mean from the box and whisker plot? Well, no, we cannot, because this does not show us all of the pieces of the data. It just shows us the 5-number summary of the data. So that one may have been a little tricky. Like I said, pause it if you need to fix anything or go back and understand the answer. And now I want you to pause it one more time and finish up the rest of the problems. Back, want you to check your answers. Oh my goodness, that got much smaller all of a sudden. I don't know why. There we go. Alright, so for this, I've given you a couple little tips. 25% is just one section. You cannot determine that exactly one student had 20 stuffed animals. We just know that this is our minimum. There could be multiple 20s in this section. We just can't see every piece of the data. This one, 25% have at least 60 stuffed animals. Well, at least means 60 or more. So that would be here to here, and that would be a true statement. More students have between 30 to 50 stuffed animals compared to 50 to 60. Now, most of you probably rushed on that one and said, well, 30 to 50 is more spread out than 50 to 60, so that's true. That is not the case. We can't tell, guys. We can only see that the variability for this section is more than the variability for this section. That means our data is more spread out than here, but we can't see the individual data points for any section, so you cannot determine that to be true or false. All right, well, by now I am sure you have a better understanding of box and whisker plots and how the data is represented. Good luck.